Yeah, so
So I called my, where'd it go? I called my group 1 was the first thing I saw was the female, so I called group 1, and this is what I get for these guys here. Alright. So how's that jive with you guys so far? Different. Different? Uh-oh. Let's see. Very possible that I just rubbed up here. Let's see if I can. Oh, there you go. I left out an 82.1.
how could you leave that out?
Because I got tired of this. So, I just broke a cardinal rule, which is, as you put your data in, the very least you want to do is make sure that you end up with this list as big as your sample is. Like, let me do this again. Alright, so now I get this. Is that better? And I got 14.85 once you round it. And there's 14 of them. And then do one bar stats on L2. I get this. How's that?
Yeah.
Alright, thank you. That's 13.68. That's neat.
Yes.
12. Kick ass. Alright, so I just want to write all that down so you guys know. Well, you can check my numbers too, apparently. What is the claim? Mu1. So again, the claim is always going to be about a mu, or a p for percentages, or a sigma for standard deviations. It's going to be about a population something or other. And that, of course, is the bless you. So it's going to be, again, it's going to be a two-tailed test. I love my distribution. Looks so good. Can't we use z-squared? I don't know why I just didn't say anything about t-squares. I think this was originally a p problem, which is where you can only use z or nothing, right? So we can't use z-scores. Why?
Because there's no population.
Yeah, don't know sigma, but why can you do anything? Because Jeff said, normally not. Alright. Cool, I like it. So now the rejection region using t-scores. Well, degrees of freedom would be 11, good, because the smaller sample size is 12. Alpha is 0.05. We're using two tails. Who's got that t-scores? 2.201? Okay. Sorry. That's what you guys sound like. Alright, sorry. You got all this stuff. Now you just got to plug and chug. And of course, order operations matters in the calculator. So again, as I was walking around, I'm not picking on anybody, but the easiest thing in the world to forget is to square those poor little standard deviations.
Oh.
Where is it? Oh, why did I put that?
Yeah.
Thank you. Divided by, oh, I just went straight down there. Divided by 12. 0.75? That sounds.
4.74.
0.745.
Oh, I love you guys. 745. Damn it. Ah. But it almost doesn't matter. I mean, that's 3/4 of a step barely away from the middle. So what do we say? Failed. Again, Java, you made us fail. Failed to reject. The hoe failed to support the high. And of course, what was the claim? It was, that's right, it was HO. Thank you for the help. So we have not found sufficient evidence. We have not. I'm just too far away from it. Sufficient evidence to reject the claim that what?
The mean scores for all males and females are the same.
Means are same for all men and women. Right? So we fail to reject that. So we haven't found evidence that they're different. So we would say they're not statistically significantly different. Okay. So what about oh, where am I at? Oh. There it is. No. Where is my other sheet? Here it is. Woo! So going back to the other sheet on the other side. So I think I'm going to make 10.4 extra credit. Let me say that again. I'm going to make 10.4, section 10.4 extra credit. If you can do it or not. We'll talk a little bit about 10.4 because I actually have one problem from 10.4 on the practice test. So it'll be on the key. We can talk a little bit about it. It's not that different at all from what we've already done. So we still have to talk about 10.3. And 10.3 is going to be about comparing two population proportions. Whatever you say, Jeff. So I need to do the same kind of thing we did here. So what was the formula for Z star? What happened? Let me finish the question. What was the formula for Z star for a hypothesis test for a percentage? It was a little different. We had to steal something from the confidence interval formula. I don't know if you guys remember it all. So I'll tell you the top of it looked like this. The difference in the two. Square root? I like it. So we stole this from confidence intervals. If you look at the confidence interval, they had hats on them. We're not going to use the hatted ones because we always use the more powerful information. If we have it, then we'll have P. So we'll have P. So that was for one sample because I only see one sample in there. So by a lot, it's one little change in reasoning. So watch this. Let's say that I take two groups. I take a group of men and a group of women. And let's say I take 47 men and I take 53 women, and 11 of the men do something and 40 of the women do something. So finally calling the men group 1 and the women group 2, what would P hat 1 be? P is a percentage, so it's got to be less than or equal to 1, right? It's got to be between 0 and 1. So how do you calculate? So again, out of the 47 total men, how many did whatever this was? 11 did, right? So 11 divided by 47.
23.4.
23.4? So what's P hat 2? Yeah, 40 divided by 53.
I think he That's right. X2,
Yeah.
40.
Oh, I put. Why did I do that? You're like, that's a good question, Jeff. We don't know either. But you should, hopefully, as you listen to what I'm saying, if I make a little mistake, you can correct me. 11 out of 47. X, remember, was a number of successes. So whatever this is, 11 men out of 47 watched the Game of Thrones season premiere. Right? I haven't watched it yet, so don't say anything.
Really?
I know I haven't. I've been a little busy. So I've got it waiting for me. And 40 women out of it, for some reason, they just go crazy on Game of Thrones. They love all the violence. It's just terrible. What do you guys get here?
27, 45.
7, 5, exactly.
5.
All right, I like it better. There are 3 places on this. All right, so far that's old news. I've got 2 samples, so of course I got to just do that work twice. But here's the new thing. See if you guys are with me on this. If I knew the standard deviation for an entire population and I took samples from that, wouldn't I use the standard deviation for the entire population, right? I always use that if I have it. So I took 2 samples of people from a population of people, right? Can't we just all be people? Why do we have to have these gender divides? So we're all just people. So this, oh shit. What, Jeff? Come on, hats and bars. But this is the pooled percentage. This is looking at everybody just as people. Don't break them down. So how many total people did I have? How many total people did I have? 100. 100 total people. Don't break them up into groups. Put them all back together. So this is my estimation for the population percentage. So 100 total people, and how many successes did I have total? 51. So thankfully that's just 0.51. So what's Q bar? Don't. It's taking too long already. 0.49.
Yeah.
This is why I said earlier, no matter what they're wearing, P and Q have to add to be 1. No matter what they're wearing. Hats, bars, right? Earrings, whatever. All right, so now the formula is going to look like this. So we are going to have 2 ends, right? I haven't given this. Oh yeah, that's right. You basically already have it down here. Let me not write it again. So it's just like, so we're going to have 2 of these. The same thing's going to happen to this that happened before. They're going to cancel the P1 minus P2. We're fighting against the assumption that they're equal somehow. So that's going to cancel. On the bottom, this is interesting. So I got PQ over N, and I'm going to have PQ over N1 and PQ over N2. I'm just going to use the better approximation for my whole population, which is the bars. The barred ones, right? Not the barred. And what's this all about? Here, where's my finger? There it is. What is that for? Yeah, to see if it's normal. NP bar and NQ bar have to be bigger than 5. I like it. Kick ass. So all the steps again are the same. The beautiful thing is NPQ problems, we never have to use T-scores. Never. That's why I wish the book would put that section before we even talk about T-scores, just to really hammer it home. We did all that shit before we even knew T-scores existed, and we actually did. I did it out of order. We did it before we knew T-scores, so we never have to use T-scores for this, ever. Let's see what time we got. We can get started on this. Guys are like, no, Jeff, please, God. Okay, let's try this one together. So obviously the claim is really easy to see here, but let me see. What are we going to call group 1?
Women?
Sure, that's the first thing I see. We'll call this group 1. And the men, the poor little men, group 2. So very often, but we're used to it. So what is the claim in Mathish?
M1 is less than.
Yeah, so you could write it a couple different ways. So I could write it, since I'm testing the claim that a higher percentage of women had less than a B minus. That's what I'm testing, right? So then P1 is how related to P2 then? I'm not sure how you can So my claim is that a higher percentage of women, so P1 represents the percentage of women. So I'm claiming that a higher percentage of women than men. So I'm claiming that P1 is greater than P2. Or you could write P2 less than P1. Try to put the 1 first, though, because that's going to jive better with the formulas. So where's that go?
H1.
H1, I like it. So what's HO?
P1 is less than P2.
I like it. So this is obviously going to be a how many tail test? 1. Where? To the right. I like it. I like that. You guys are to the right, Joe. Points me in the direction. Okay. We know it's not T. Why is it Z? What do we check? Well, we check, again, I don't know why I put that way down there. So we need to calculate P bar. Let's do that. What the hell is P bar? How do I calculate P bar? So it's going to be, how many total people? 186 plus 158. That's how many total people. And how many total successes? 92 and 62. All right, so it'll be, 154 out of 344. Okay. Thank you. So I get 0.448. Q bar would be what now?
0.552.
552, kick ass. Some guys might realize NP bar is just 154. So that's bigger than 5. Hopefully you realize. Or just do 344 times 0.44. Of course you're going to get 154. And Q bar is going to be the rest. And Q bar would be 190. So if you do the work, and Q bar and P bar, I get bigger than 5. What does that mean?
Normal.
Normal enough. I like it. So then we can use z-scores. Right? It's the beautiful thing about NPQ. It's got if it's normal, you can use z-scores. If it's not, we can't do shit. At least in Stats 1, which is where we are. So I know I'm using z-scores. I know it's a one-tailed test. Alpha 0.025. So what's that going to be? One-tailed test, alpha 0.025. You go all the way to the bottom to get that z-score, right? 1.96. Oh. So in words, how do I say that? If Z star is, we can what? Reject the hope. Support the high. Alright, so now we haven't calculated p hats yet, right? So we need to know what p hat 1 and p hat 2 are.
P hat 1 is 0.495.
0.495?
Yes. And P hat 2 is 62 over 158, which is 0.392.
That's pretty different.
Oh.
Oh.
Is it?
No, I mean,
Oh.
I didn't know
Oh.
what, I couldn't remember. It's been a while since I did this worksheet. But, I mean, when you say that's 10% difference. That's pretty substantial, right? But we're not exactly sure yet. Z-score will tell me if they're different enough. How are we doing so far, Zach? We've done this kind of thing before for confidence intervals. Calculate the P hats. So now you just got to be careful about how you plug it in the old calculator. And now, watch how important this is. I really want this to kind of make sense, but I'm just going to say this real quick. See how the tail is up here? So my z-score should come out positive. But if you put them in the wrong place, it's going to come out the wrong sign, and you're going to misinterpret the test possibly, right? You guys see that? That's why the 1s and the 2s are very important. See how the formula is all about 1 and then minus the 2. So you want to keep the 1s first all the way. You want to, I don't know if you guys kind of see what I'm saying. You're going to end up on the wrong side of the picture if you're not careful. And P bar was 0.448 times 0.552 all over 3, well, no, sorry, what was it, 186 plus 0.448, 0.552 all over 158. All right, so it's P bar, Q bar over each end. They each get a term. So now there's a lot of stuff. Just make sure that you stay under that square root when you put it all in. Make sure you put the top in parentheses. Let's see what we get. Where everybody just pretends they're doing something, waits for me. This is the same here, right? It's P bar, P bar. P bar, P bar, Q bar, Q bar. So it's 0.448, 0.552 divided by one of the numbers. 0.448, 0.552 divided by the other one. N1 and N2. They each get a term. Where did I... Oh shit, where am I at here? Okay. Somebody got something? Oh man. Got so close.
P bar, Q bar.
You guys, anybody want to hazard a... So there's 0.495 minus 0.392 divided by 0.448 times 0.552 over N1 plus 0.448 times 0.552 divided by N2. And you get the 1.91. That's what I get. How'd you guys get 1.91? Now you speak up. All right. 1.91. What's the p-value? Remembers how to find the p-value. Where's alpha on this picture? Where's alpha on this picture? Where is it? The shading. Beautiful. Alpha is the area in the tail that your critical score, your rejection z-score makes. P-value is the area in the tail that your z-score makes. So what's the area in the tail of 1.91? So if you look it up, 1.91. I get 0.9719. But is that the right thing? Is that in the tail of it? 0.9719 would be down here, so I got to do 1 minus that. So is it 0.0281? The p-value is the area in the tail that your z-score makes. So that's the p-value in this case, 0.0281. How does it relate to alpha? What was alpha? 0.025. Now think about this. Come on now. If my z-score makes it in the rejection region, its tail is going to be smaller. Think about that. If you look at it, if my z-score makes it in here, its tail would be smaller. So its p-value would be less than alpha. My z-score, did it make it in there? We didn't make it far enough. So its p-value is going to be bigger. So that's why they only report p-values when you read articles. They only tell you the p-value as a result. Because then you're able to make your own choice. Because then, what's alpha? Maybe my alpha is different from this. Yes, ma'am? So there's my z-score I got, right? Now find the area in its tail. So if you had 1.91, what's this area here? That's old news. So if you look it up, you got to do 1 minus. Exactly. See, that's old news. So the p-value is the area in the tail of your z-score. Comma. If it was a two-tail test, you would just double this. That's the only difference. But this is a one-tailed test, so I don't do that. Okay, I like it, maybe. So what's my conclusion? Did we make it far enough? Nope. So we have not, just all day long, man, we've been failing all day long. We have not found sufficient evidence. To what? What was the claim? Yeah, I want to use support language. The claim was the H1. We have not found sufficient evidence to support the claim that what?
Women have less.
A higher percentage of women had less than a B minus. So I could just use the exact language. Higher percentage of women had less than a B minus. So if you try to whenever we do something on campus, we actually have to show that it's not got too much disproportionate impact. So like if one group of students was affected more than another, we'd have to work something out about that. Does that make sense? So we could run a test like this on GPAs after we've done some change, and we pray that we don't find evidence. We want them to be equal or not statistically significantly different. We want them to be basically, we want to not show evidence that they're not equal, because that would mean we're treating people differently.
9.
All right, that's plenty. Everybody got a practice test, right? Yay. So next time's review.
9, 7.